Find the zeros. In this problem, we are going to find the zeros of the function and their multiplicities. Okay, so you have a cubic function. F of x equals x cubed plus 2x squared minus x minus 2. So to find the zeros, we need to think about what are the x values that gives you 0 for the y. That, what are the x zeros where y is 0. So the first step is going to do what? Set f of x to 0. We did one problem when we have the function written in factored form. That's fine, which is straightforward. I can use the zero property. We did another problem when we have a quadratic function, or a quadratic function. And we did another problem when we have a polynomial of the degree of 4, but the polynomial looked like a quadratic function. So we did the factoring technique that we learned to factor that polynomial. In this case, we have a cubic function. Okay, so I'm going to try using the grouping method. I'm going to use the first two terms and the last two terms to do the factoring. So this one, set this one to 0. We said set this one to 0. Okay, so it's going to be x cubed plus 2x squared minus x minus 2 is equal to 0. Then I'm going to group the first two and group the last two and take a common factor among these two groups. So the first group, do we have a common factor? Yes, we can pull x squared out. So x squared is pulled out. So what is left in the first term? You just divide, okay? So I'm going to divide. X cubed divided by x squared is just x. Then plus here, plus, bring it down. Then divide the second term over that factor that you pulled out. So 2x squared divided by x squared is just 2. Then we finished from this group. So I close the parentheses. The second group, we have negative x, negative 2, so I'm going to pull the negative out. So the negative will be pulled out. So when you pull the negative out, the first term, divide the first term by the negative 1, which is the negative 1 that I pulled. So x stays. Then negative 2 divided by negative 1 is going to be positive 2. Because I did not pull the negative alone, I pulled the negative 1 indeed. So this one is equal to 0, right? Now, the lovely thing is what? Is that we have something similar here. We have two terms now. We reduced that polynomial with 4 terms into a polynomial with 2 terms, okay? With 2 terms. This is the first term here. This is the first term, and this is the second term. And the good part is we have 2 terms and you still can pull a factor from these 2 terms because there's something similar, right? X plus 2 is the same as x plus 2 in the second term. So I can pull it out. I can take x plus 2 out. When you take it out, what's going to happen? You're going to divide, or just ask yourself, when you pull it out from here, what is going to be left? Just x squared minus, when you pull it from here, what you are going to have? Nothing. It's not nothing, it's 1, because you divide by the same factor, you get 1, right? So x plus 2 minus, or divided by x plus 2 is going to be only 1. So this is 0. Good. So we got something nice because we have x plus 2 and we have x squared minus 1. So x plus 2 is a linear factor. So we are done from the first guy. The second guy is a quadratic polynomial, and we can do what? We can use the difference of two squares. We can use the difference of two squares. So what I'm going to do is x minus 1 times x plus 1 is equal to 0. So we factored f of x completely. It's a product of three linear factors, and each of them has only one of them. We have only one of them of each of these different guys. Okay, these are different three factors indeed. And how do we find the zero? The zero is use the zero property again, because the first factor times the second factor times the third factor is equal to 0. Then equate the first one to 0, you get x plus 2 is equal to 0, or x minus 1 is equal to 0, or x plus 1 is equal to 0. Then solve the first one for x, you get x is equal to the negative 2. The second one, x is equal to 1. The third one, x is equal to the negative 1. Which one is the smallest? Negative 2. Which one in the middle? Negative 1. The largest 1. And the multiplicities, we have only one of them in each, because each factor raised to the power of 1, right? So this is 1, this is 1, this is 1. We have only 1, 0 from each of these guys. So the smallest 0 is what? Negative 2 multiplicity of 1, then negative 1 with multiplicity of 1. Then the largest 0 is 1 with a multiplicity of 1. Okay.